And we should be...
Okay, I found live now.
Should be live.
Okay. Close that chat. Okay, and we'll wait for people to come back, I guess. Sorry, I'm not sure what that was, if it was sharing screens or... See, it looks like it's still buffering on my end. Now, I don't know if that's just going to be for me, just because we're coming back, or what.
Well, I see it coming back now.
Okay.
Okay. All right. Sorry, guys. I don't know. You know what the deal is? You know, I'm trying to add more and more and more, and until we actually work out the kinks, certain elements are probably going to end up having to wait until I can optimize the video. You know, hey Ron, he's on his own little world there. He might have been typing to people who didn't even know he was typing.
Yeah, he was having some issues earlier.
He was? Why?
I don't know, he couldn't find my show to start on time. And
Oh.
he was panicking, so he went to check to make sure he had Bill's show for tonight, midnight Eastern, Skywatcher's Midnight Metal Madness. Be sure to tune in Dirt Radio. And then he went into a panic because he couldn't find that one either. But he found it now.
Oh. Ay, ay, ay. The problems of having a radio station.
Alright. And thank you, Marianne. A few people were commenting on Sky Tour Radio, saying that they've been enjoying previous episodes. Just so you know, there will not be a show this Sunday. For some reason, people want to watch football. So, just Super Bowl being this weekend, we decided to opt out of a show, of a live show. But there will be a replay.
Yeah, there'll be a replay on there, and I will. I'll determine with our producer which replay to play. If you have any ideas, let me know. I'll pass it on.
Yeah, if there's any you liked in particular, by all means.
Exactly. Hey, Daryl, welcome back.
Daryl on it, nice.
Yeah. Well, I'm just sitting here, just letting it stabilize. I mean, we're actually showing quite a good health for the stream right now. I think maybe the package I was using was too computationally intensive, and that probably caused the problem that we saw. So I'm sorry about that. I'll optimize it and I'll make it work for the next time, I guess. But man, it's beautiful seeing the universe in 3D. So that said, not a problem. It doesn't mean we can't still do what we want to do. We always have fun in SkyTour Livestream. So let's go out to our planetarium. And
At least you said me joining didn't cause the problems.
oh, actually, speaking of that,
No, you can't go back now.
what?
It's a computer issue.
Oh
Not
no,
me.
no, I'm not. I'm
Okay.
I'm sharing the screen again.
Are you on Skype?
Yeah. So now.
Oh, perfect. Oh, I didn't know. Let me pop out chat.
Yeah.
Okay.
Yeah, thanks, two guys for coming back. I know that, like I said, it was kind of a nutty thing, but Charles is here, Cosmic's here, Daryl, you, Amanda, Ronald, Johnny Unitas, Laura Newbert, thank you. Marianne is here. Hey, Marianne, what's going on? Raymond is here, and is that Weird Guy? Is that what it says, Weird Guy? That's supposed to be Weird Guy, right?
His name's John.
Okay, John.
Yeah, the I and the E are the number 13.
Yeah, I see
Weird
that.
Guy.
I can see that. I don't know the significance of the 13 though.
Just being weird.
Okay.
Hence his name.
Hey, I know. Let's call him Weird Guy. Oh, wait.
Ah.
Never mind. We are. Okay, that's kind of weird. All right. No worries. So I want to thank you guys for showing up. We will be continuing here and checking a few things out. And
we have a request already.
I saw that.
Okay.
So let's go see.
See, I can just sit back and relax now that you got chat up.
No, it's okay because I'm not necessarily going to be able to. I don't know if M79's in our field of view right now, though. Actually, yeah. Okay, I think I can do that. Yeah, right down here. M79. I think I should be able to see it. I don't think I have a problem with the dome being too low at that point. I know that there's problems with that, but it's going to be 20 degrees. So we'll try it. You know, it's way down below Lepus. Let's see if we can do that. Shall we? Okay, what is it? Well, what is it? First of all, it's a globular cluster. Globular clusters are these wonderful spherical collections of stars that are just amazing. You can have anywhere from 10,000 to 150,000 or more stars, all in this spherical cluster. And I think that they're really important to the universe, to our galaxy in particular, because we have a halo of them around our galaxy, and they orbit the galaxy, which is kind of cool. Let's go see if we can get ourselves to it. We're moving to it, I can tell you that. Okay. All right.
See, I remembered. I forgot something, but then I remembered. I was thinking, who's Lepus? And I was thinking, he sounds like he should be a frog. I'm like, no, Lepus, the hare.
You got it.
I remembered.
That's right.
I wouldn't have remembered the designation, though.
Yeah.
That's not what was it? M79? That's not Lepus.
No. Well, I don't know if it's in Lepus. M79 might be in Lepus. Yeah, there it is. And we see we're getting just a little bit of the dome in here. That's part of the problem we got right there. That's what I was concerned about. Little tiny bit. Okay. And let's just... Yeah, there it is. It's pretty.
Yeah, that's pretty.
Yeah. The stars in these globular clusters are usually... They lack elements... They lack elements beyond hydrogen and helium, pretty much. They actually don't have an abundance of those other elements like our sun does. You know, our sun has calcium and magnesium and phosphorus and neon and oxygen in its atmosphere, the atoms made in other stars that it was made with. The sun doesn't make those elements because it can't fuse elements that heavy, so to speak, in the periodic table with that many protons, neutrons, and electrons. And they can't because of the fact that the temperatures don't get high enough to allow that type of fusion of atoms to occur. But that's okay. I mean, we actually, the sun is made with other elements that were created in other stars. But most of the stars here in these globular clusters, these are devoid of those other elements. And we call those other elements metals. Anything other than hydrogen or helium, we call them metals. It's not because we don't know chemistry and astronomy. It's not because we're ignorant of the actual names and nomenclature. It has to do with the fact that it's a traditional examination of objects that are created in the fusion process. And so we talk about metals as being anything other than the elementary elements, hydrogen and helium. So, I mean, maybe lithium, okay? Because, lithium and beryllium were, made early on in the universe, and that was kind of all there was. So there's M79 to give Cosmic his wish come true. And if I were to move the dome a little more, then we would probably have a better view of it, a little bit better. And I'll do that. I'm still working on my dome rotation mechanism. It's still sitting here to my right and behind me, working on it. But I ended up, I picked up with my business, which I have a model making business, of course. And, that was what brought in the money, and still does. So I actually picked up some work to build a Navy warship, which is going to be coming in any day now. And then another submarine model that has to be ready to go down to Washington in May. So I got a lot of work coming in. And these are not small models. These are good size. That'll take me some time. It won't prevent me from streaming. It won't prevent me from doing this stuff. It'll just mean that I'll probably stream more frequently. And I will probably, while streaming more frequently, I'll probably make them shorter. So I might actually stick to 2 or 3 hours instead of going over 5 hours like last time.
Yeah, we'll see.
I know. I always say that, don't I?
Mm-hmm.
Keith always says that too. Hey, why don't you come on for an hour? Okay. 3 hours later. Well, that was a fast hour. Yeah, it was 3.5. Oh. Yeah, that's how it works. What can I say? So, back in here. So, M79 is sitting right down here. And let's see now. Let me grab something here. All right, there we go. Okay, now, if we're gonna play around here with some other stuff, Ronald says my name. What's the matter?
He wants to know if you're using your telescope.
Yeah. Yeah, Ronald. This is the views we're looking at are out of the telescope. I mean, it's this object right here we just saw. This was taken right in the telescope moments ago. I'm not sure why the question. Maybe he's, I don't know. See, where he lives, he lives on a postage stamp. The town is a square, and you can walk around it. It's an amazing place, and you got to visit it someday. You just have to, It's just an amazing little town he lives in. I'd really be amazed to see it. I think the skies might be pretty good there too, but he knows. He'll tell me. So this is Lepus the Hare. This is the constellation we're looking at right here. There's the Hare, Lepus, and the thing we just looked at is down here, right near the bottom. Okay, that's the M79. Okay, that's in Lepus.
It's a lucky rabbit's foot.
I guess it is, isn't it? Yeah, this foot, as a matter of fact. All right, cool. So now let's go up, and while we're here, and before I move the dome to look at other things, let's go take a look. Let's go up to Alnitak one time and make sure that I want to check out the Flame Nebula. See how it looks tonight. I use the flame as a indicator of the night. If it looks nice, if I can get a really good shot of it, if it looks pretty, then I know that the Flame Nebula is actually, a good indicator because it's subtle. It's got some subtlety to it. So
Flamey.
Yeah, flamey, baby. Okay, so there's Alnitak right there. You can tell Alnitak has this little tiny star next to it right there. Okay, and that's what's interesting about Alnitak. So we got that right there, and let's see now. If I were to just add a little bit of the focus here, well, not focus, but I want to bring it up in a magnified view so you can see. Well, if only I bring it in the view, not out of the view. Okay, so there's Alnitak right there, and this little tiny star next to it. Okay, so you can see them there, and that's nice. So now what I'll do is I will...
What's the little one called? Is it like Alnitak B or anything?
Yeah, I think so. Let me look at the... let me look here and find out, because it'll be on this too as well. I think we're actually talking about a star that's right, maybe here in this glare. It's not this star. I don't think it's that star. Okay, I think it's actually a little tiny star right there. So I'm not sure. I mean, Alnitak actually is a double, and it is there is an Alnitak B, and that might have been Alnitak B. I'm not sure if it's a spectroscopic, meaning you can only see it in the spectrum, binary star, or not. But it's possible. Right now, though, I think I'm going to just zip us over here and bring us up a little bit because I want to see the flame, which is right about here. So let's do 20 seconds at 12,800. All right, and take a picture. So we take this dark patch of sky where we don't see much of anything. And you can see from our telescope view, we're looking right out of the dome slit. And then we're going to see if we can actually see the Flame Nebula and better than we saw it the other night. It's actually crystal clear tonight. It's supposed to cloud up later, but you know what? We'll wait and see. Okay, so now we actually see the flame here, but okay, if we add some processing, okay, instant processing. It's a little instant process I like to add for you so you can see something right away rather than have to try and look through haze or whatever. So you can see now that the nebula is actually showing, it shows okay, right? But it's still not quite in the position where it'd be ideal. So there's still some time. We have to wait for Orion to come up a little more. Hey, James Dugan from down under Australia. Mm-hmm. Nice to see you. Thanks for coming out. Thanks for hanging with us. Oh, Daryl, I'm glad Daryl says it's sunny and clear where he is in Colorado. Yeah, but you know what? He also has winter. And I don't want winter.
He said, I don't know if it was yesterday morning or the morning before, he got up early and saw, I'm going to mess it all up now. He saw Venus and Jupiter and Saturn, I believe, and Antares.
Well, Antares would be
all before sunrise.
Yeah.
No, Aldebaran.
Aldebaran is up now, though. You might have been right with Antares. I think Antares is probably the one you were talking about.
Maybe.
Yeah, Antares is westward of the sun, so I'm sure that you probably were looking at that. He was probably looking at that. Yeah.
It sounded beautiful.
So there we go. We got that. Yeah. You know, sometimes you don't need a telescope. Sometimes you just need your eye. You know, just your eye. You know. Let's do, I'm going to go up to 16,000, up a stop, and take another photo of the flame. See if we can get a little better rendering of it. 20 seconds for 16,000 ISO, and we'll see what we can get.
There it is. Venus in conjunction with the moon, with Jupiter and Antares in the Scorpion.
That's right. Yeah, I figured it was Antares.
Saturn is to the lower left.
Yeah.
Yep. Yeah, I knew Saturn was in there too.
Sure.
And I knew Jupiter and Venus, yeah.
You are smart.
It's not that unusual for Venus and Jupiter to be seen together, is it? Naked eye.
Well, you got to understand that, you know, Venus goes around the sun a lot faster, than Jupiter, of course. So it stands to reason that since they both move through the ecliptic, that is the plane of our solar system, pretty much, that a couple times a year, you can expect to see, it's just about on the order of 3/4 of a year. Every time 3/4 of a year comes by, you can expect to see Jupiter and Venus near each other for some period of time. Whether you can see them or not depends on where the sun is, because Jupiter would be harder to see than Venus. I've shown people Venus in the middle of the day, and pointed it out. And when they saw it, it's like a little tiny pinpoint in the sky. You can actually see it with your eye if you know where to look. Yep. So yeah, here's the flame. It's an interesting. It looks reasonably good tonight. I like it. I think that it's giving us something to look at. And I'm gonna just see what some of the instant processes can help me with here. Just a little working on this. Okay, we're gonna leave it right about there. Yeah, just to see. That's nice.
I wish it was more red.
The flame?
Yeah.
Well, let's see. I mean, we can actually change the color. Like that, and then we can probably shift some of the colors. You know, these colors aren't correct, but they do help. They do help you to figure out what you're looking at. You know, hey, Missy from Alabama, how's it going? Welcome, welcome, welcome. Very pleased that you could join us.
Welcome, friends, new and old.
Yeah. Okay, so very interesting. And now I'm going to go back to our regular view here, and let's go to our view, and let's look for other things. Might be moving the dome soon. I mean, since the last stream had this in there, I'll do it for this one because I know that people would like to see it anyway. We're looking, of course, at the Orion Nebula right now. The Orion Nebula, it doesn't really ever get old, you know, because there's so much that it has to offer us, you know. So when we look at the Orion Nebula, we actually see
Orion's Nebula.
Well, yeah, we see the evolution of the universe taking place right before our eyes. You know, 1,600 light years away from us is this nebula. It's actually fairly close. You know, it's a naked eye object. You know, and if you think about it, just by going into a 4K video mode here, we can increase it to kind of show you what it looks like to your eye. If you look at a telescope, you can see it like this. Actually, I'm just going to do one thing. I'm just going to just bring it up a little bit more. Okay, that's good. So this is what it looks like to your eye in a moderate-sized telescope. In a bigger instrument, then you can actually get this, and you can actually see the reconnection of the wispy structure down below here. And so if I can just go up higher, this is 204,800. This is 256,000. It's messy and noisy, of course. But if you had to look at it and look at some really specific objects, sometimes that speed is essential. But as we zoom down here, as we reduce the exposure, you'll see that something else comes in. And that is these stars right here in the middle. This, of course, is the trapezium. It's the center of Orion. And these stars are the most amazing 4 stars in our neck of the universe, because they are the powerhouse for a part of the nebula. Okay, and this is just an extreme close-up to show you these 1, 2, 3, 4 stars, trapezium, and they are illuminating quite a lot of this nebula with their ionizing radiation. It's quite effectively done, I have to tell you. So that's that. Now let's just take a photo. Let's go out of the video for a moment. And we'll drop.
What number is the Eagle?
That's M16 in the summer sky.
16?
Yeah.
Is that the Pillar of Creation?
Yes, it is.
Woo!
You got it. Now, 3200 is the ISO, and you know we can go really high, but I'm going to do 20 seconds at 3200 just to show you the subtleties in this nebula. It's really, really pretty. Excellent, Missy. Thank you for coming out. We hope to make you have a good time tonight. Here with us on the Sky Tour live stream. And that's the other thing. If you take part in the chat, you're going to get shout outs, talked to directly. You'll get instant gratification. We're not going to sit back and make you just a spectator. We want you to be part of it. There now. This is why I did this at 3200. I want you to take a look at this side of the nebula, and I'm going to actually give us a little processing here. I'm going to pull that back a little. I'm going to get it right now and pull that back a little because I want to show you something in specific.
I love those colors.
I know you do. I know you love those colors. Okay, so pull back these colors a little bit. Now take a look at that. That is a very interesting location. Okay, because this knotty structure here, this is actually an area of the nebula where there's a lot going on here. There are stars forming here. There's possibly solar systems forming in here. And if we see it native, the way that it came out of the camera, okay, then it looks like this. So it's a little less subtle, but it's actually less noisy this way. But the green...
If there's a solar system being formed there, will it just stay there?
Well, it's forming within this cloud of dust that's thick in here. This is black dust that is crossing over the bright part of the nebula behind it. Okay, this is sitting over like a tongue of black. But that's... this is all moving in space. It's all moving around the galaxy and orbiting the galaxy. So that's something that that's something that we would have to follow. If we could track their orbit, we know how fast the stars are moving. So we know the general trend for where all this gas and dust are moving. And so that gives us an idea where it's moving to. So we would know where it's going to end up over long term. Now, Daryl mentioned something in chat, which is very important. And that is that we don't know that these solar systems are forming in here, or these star systems, by just looking here and going and say, let's just zoom in and see these star systems. So we see, oh, look at that photo's not even a good one. I got a tracking error there. I'll fix that. So the reason we know they're there is because we don't look at the nebula using a regular telescope like the one I'm using now with you guys. We look at it using an infrared telescope. Infrared energy is energy you can't actually see with your eyes. You can see what it does to the air. It makes the air ripple on a hot day off the road. Okay, that's infrared radiation rising off the road. But so the problem is that infrared radiation also, because it's heat, there is latent heat in any compressed area in space. That is, anywhere there's mass that's accreting or coming together. That mass is closing down and on itself, compressing. That compression generates heat energy, and it might be small. It might only be a few degrees Kelvin, a few Kelvin, I should say, a few Kelvin, all right, in amount. But it is actually something that's very noticeable to an infrared telescope. So we would see concentrated focuses in the nebula. Maybe perhaps here and over in here on a front here, a shock front here, where this material is being pushed by some stellar wind from stars out here somewhere. Okay, and maybe we'd see some shocked areas where there's little globules forming of dust and compressed gas that is being ionized or whatever. And those little dark globules, I met the guy that actually named them, Bart J. Bach. He was I got to meet Bart Bach, and he taught one of my classes. And he is the guy that came up with the object called the Bach globule, and his name was spelled B-O-K. A Bach globule. And it was kind of cool that the Bach globule indicated where these infrared energy concentrations were. That was good, because now we knew where to look for planets, potentially, and for other stars that might be forming. And initially, what's funny is, initially we actually looked for, stars, and we didn't even think about planets. I say we in the collective sense. I always knew there were planets out there. I've always thought that. I've never, ever deviated from that. I always known there were more planets than stars in my mind, but I was roundly criticized for saying that. You don't go far in academia if you say things like that. Turns out I was right. But that's okay. I mean, how could I be wrong? Look at the universe. I'm taking another 3200 for 20 seconds to get another picture, see if we can do a little better than we did before. Yeah, Cosmic is right. There's the process of formation of planets is not a simple thing. Just think, oh man, how about that? It looks like the Orion Nebula is trying to run away. I'm going to do that again. Not sure why it's doing that. Anyway, Cosmic says, looking at solar systems around other stars indicates it's a pretty complicated process. Yeah, it is a complicated process to build a star system because you have to have the material on hand, the ingredients. And that means that the local interstellar medium, that is the area around that star, has to be filled with a plethora of elements, atomic elements, from which to make these new stars, for one thing, and then the planets from the debris left over. And that debris is going to consist of all the atoms now that are there. Now, if you look in our crust, the crust of the Earth, the soil, what it's made of, very complicated mineralogy. But the universe makes that in abundance. And it's through places like this. The Orion Nebula is a stellar nursery. The stars born here cause the nebula to shine and glow and reflect light, right, like here, okay, and emit light like here. This is the soft glow of the hydrogen alpha we've been talking about. Okay, this sharp border right here is probably the neatest spot that you can see with your eye when you look through a telescope. This is a very sharp delineation between a hydrogen alpha region and then this reflection region here. There's a lot going on here. But again, it's also very complicated. There's a lot of other processes going on inside all of these nebulae. It's not like they're just emission or reflection. Okay? Because you can have an emission nebula that's giving off green, can't you? We know that. We've looked at the dumbbell. We know that's doubly ionized oxygen, O3. And once again, O1, okay, Roman numeral 1, is the base state, oxygen with all of its electrons. If you ionize it once, throw it off an electron, it becomes oxygen 2, O numeral, Roman numeral 2. And then O3 is the doubly ionized oxygen. So, again, we bring you these very interesting changes to the way simple understanding ought to be. And we love acronyms, and that's kind of what we do. Like during the eclipse, when we caught the meteor striking the moon in the Sky Tour live stream, so did Midas. Midas? What's Midas? Well, Midas is M-I-D-A-S. Yeah, but didn't everything Midas touched turn to gold? Yeah. What's Midas mean?
I know.
Yeah, what's Midas mean here? Midas is the moon impact, okay? Moon impact detection and analysis system. Midas, M-I-D-A-S. And Midas is set up in Spain. It's a network of small telescopes that actually watch the moon for such impacts. And they caught the impact on the moon during the eclipse, And because they use infrared telescopes as well, they were able to measure a lot more data points about the impactor and its, most importantly, its energy. And it looks like it might have been it might have made a crater about what did they say? Was it 40 feet across or something like that? It was like a. I have to go back and look. I looked for the actual data, and I saw a few stories reporting what they thought it was, but I'm not gonna try and say that, unless I know.
And speaking of kings, Laura had a question.
Sure.
Wondering why ancient Egyptians focused so much on Orion and Sirius.
Well, actually, Orion is a equatorial constellation. It's pretty much as much above the equator as below the equator, and it's central, and it's very, very bright, and it's a very noticeable. You can't miss it. So Orion would tend to be a focus. Now, why is that in real life? Why? Because mythology says so? No. It's because of the fact that where we are in the galaxy is a location that is near something called the Orion Spur. It's an element of a spiral arm that has all of Orion in it, and its associated stars and nebulae. And those associated stars and nebulae being in this location are why why it seems so bright to us, because we're near it physically in the galaxy. And what's near? Well, 1,500 to 1,600 light years away. That's near. Okay, compared to some of these nebulae we see, which are like 4,800 light years away, 5,000 light years away. The Orion Nebula this here is only like 1,600 light years away. Ain't far away, comparatively. And that said, that gives us, that tells us, gives us an idea why we can see so much beautiful details, see so many things going on in there. And, if it's happening in the Orion Nebula, it's happening in other nebulas too. So that's why being near Orion is kind of a real plus for us.
Cool.
Yeah. Yeah, that's right, Laura. That's right. That's right. I think it was like you said, a 40-foot crater. I was looking at preliminary data, so I'm cautious. But yeah, it was probably like that. And I mean, a 40-foot crater, well, you measure 40 feet. But imagine that striking the moon at a number of kilometers per second. That's gonna be a small object comparatively to the crater it makes. So it wasn't a very large object, but when it vaporized, the light was visible for a long way away, as you could see. Couldn't believe we caught it. I know we weren't the only ones, of course, but man, what an interesting achievement to share, So I'm very pleased with that. Yeah, Daryl, good. Thanks, Daryl. That's actually cool. Did you see that, Amanda?
What's that?
Read Daryl's comment. And those of you out there, you can look at the chat.
Very cool. He says the Egyptians also watched for Sirius to rise just before the sun. They knew that it was then time for the Nile to flood and to prepare for planting after the flood. Very cool. I think I've heard that somewhere before.
Did you?
But Daryl is a wealth of information.
Yeah,
always pay attention to him in chat, guys.
Yep.
He has a really nice way of explaining things, and he'll never make you feel stupid, so that's why he's a mod.
Well, yeah, but I mean, even people who aren't mods don't make you feel that way necessarily.
No, I hope not. I don't think anyone in this community ever... I mean, unfortunately, in saying that, I just had to slay a troll. But for the most part, it's a wonderful community. Everyone's really, really helpful and really supportive, and we're all here to see the beauty of the universe. We're all here to, gain some new information, share some new information, share your points of view, and I love this community. You know that.
You slew a troll, huh?
I did.
Gads, who was it you slew?
I don't know. Killed him too fast.
Okay.
Once the head rolls, it's off my mind.
It's like, heads will roll. Wow. All right, so we're poking around here on Orion. And I was saying last night, I'll show you just real quick. Last night, this is Cancer over here. How do you know it's Cancer? Well, we can actually show you with this. Okay, there's the crab. Okay, and then right next to it, okay, you have Leo the lion. This is Leo the lion. You'll notice that we have Regulus down here, the front of his chest, and then we have the head of the lion right here, and these stars. Those are actually very prominent. You can see them very clearly.
What's the head called?
Well, that's the head of Leo the lion.
It doesn't have a name, like Regulus?
No, Regulus is a star that's right here.
Yeah, what's the star of the head of the lion?
Well, that's
What's its name?
That's Alganubi. That's this guy.
Alganubi?
Alganubi, see?
Alganubi.
Yeah, that guy.
No, I can't see that writing that small. Okay, I can see now that it's a little bigger. Yes. Alganubi.
Alganubi. Yeah, that's the head of Leo the lion, the eye. And then we have Adafara, and we have Algieba. Obviously,
for the main, I guess.
Yeah, Arabic names. Yeah. Okay, and then of course the tail of the lion back here, Denebola. Okay, down here is the tail, right? And we have where it meets the butt over here, Zazma and Shirtan. And now, but in the sky, what you see is, well, not even that. You actually see this. Okay. And without the star names. So you actually get used to seeing this little hook in the sky, this backwards question mark, and a triangle. Okay. But what's neat in Leo the lion is when Leo does come up, we actually have an awful lot of objects in here. There's a number of galaxies. I mean, a really, really huge number of galaxies. And last night I took photos of these two guys called the Leo triplet. You know, and actually I just did these two of the triplet. Okay.
Aw, don't let one feel left out.
You know, from that many tens of millions of light years away, it'll take some time for them to get me back. But every single little oval you see here is a galaxy, right? And that means a separate whole, I call them island universe, okay, of potential life, okay, with billions of stars each. And when you look and you go deeper and deeper, this program doesn't show it, but when you go deeper and deeper, you see even more galaxies amongst the galaxies. So that's, you know, the Hubble telescope did what's called a deep field, and man, it was absolutely incredible to see just how many galaxies there were in a
almost
very
like it's a populated universe.
Almost like a populated universe, yeah. And it really is a populated universe. Amanda's referring, of course, to my book, The Populated Universe, which is my basically my whole treatise on the fact that I believe that life in the universe is the rule, not the exception. Because everything that happens on this planet happens toward the express purpose of creating a life form. And I think that's really kind of the big takeaway here. In March, I'll be in Laughlin, Nevada, talking at the UFO MegaCon. In April, I'll be in Ozark again, in Arkansas, and this time they asked me specifically for a specific talk, and it's about the hunt for extraterrestrial life. And that one's going to be like 12th through the 14th, I believe. And I spoke there last year, and I did the toilet paper history of the Earth. So I guess maybe they liked it. So it's kind of cool. And when we talk about the universe as a whole, in general, the universe is trying to kill us. Everywhere we look, there's danger out there. It's only on these worlds that the danger is mitigated a little bit, you know. So when we look on the Earth, for instance, and look at all the life forms, we find that every single niche on this planet, every single niche, has a life form that's adapted to those conditions. A mile down in the Antarctic ice, in Lake Vostok, hasn't seen the sun for oh gosh, I forget how many tens of thousands of years. Okay, life exists in that lake. It's not a sterile environment. Life exists a mile down under the ice. There's a lot of weight on that water, and that water is pressing down on anything underneath it very, 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 powerfully. So life exists there. Life exists in these hot springs that if you dipped your foot in them, your foot would be burned. And you couldn't survive for a mere fraction of a second in these hot springs. Yet there's life that exists and thrives in there. So we find that life has exploited every single niche on this planet. There's really no one spot where life can't exist, except perhaps inside of flowing lava. That's probably the only one. And perhaps that's because we haven't found it yet. Maybe there's a microbe that's really into the heat, but I doubt it. I mean, that is pretty much a sterilizing factor, And Ronald's going to Pine Bush this year. Yeah, I know. Yeah, that's good. Nice.
He wants to know if you're going.
Oh, yeah, I'm speaking. I forgot about that. Thank you, Ronald. That's May.
You didn't forget.
I did.
It slipped your mind for a second.
I did. I forgot that to mention it. I'm sorry. It's true. And so it's really kind of nice. I get to do these talks and so forth. But I'll be honest. We're actually having sort of a change to the things I'm doing. I'm not only speaking about UFOs and so forth now. I do speak about exoplanets because they're actually becoming more important, But let's see here. I want to take us someplace now. I want to grab a couple of objects here. I think that these objects here are still out of reach, but I'm going to just go to Sirius, okay, for a second. Let me be serious for a minute. I'm a star. Ba-dum-bum. So let's go here.
Holy cow.
I know that was bad. I want to see just how badly the dome is impinging here. Okay, here is my Sirius. And after we lock in, I'm going to okay, and now we're going to move this way. Yeah. I got to tell you guys, to me, the most amazing thing is being able to actually be inside and do this. I mean, the show would have been over already if I had to do it outside. Okay, 20 seconds at 3200. This will tell me whether I've got anything impinging. It looks to me like I'm looking straight out of clear aperture over here in the dome, so I think we're covered. I think we're golden. Yep. Hey, Mojashi. Hey, how you doing, man? Thank you for coming out. Yeah, there we go.
Beautiful.
As you can see, Sirius is a very bright star. We see this artifact here, along with this flare up here. This is a lens flare. This artifact here is generated by the brightness of the star itself. What I don't see is the good thing, and that is interference from the dome. So I'm going to give us just a little bit more of a movement, some movement here to see if we can find another object to check out. I have an idea where I want to go, and I'd like to show you. So I'm going to take us down. I want to go down here. Yeah. Who was it in our last stream who talked about Unergonite, the star Unergonite?
Oh, really?
You don't remember? No.
Nope.
Okay.
You'd think I'd remember a name like that, too.
I don't know. Maybe.
know. If someone asked about an ergonite, let us know.
Yeah. All right, I'm going to go here. I want to go to the Skull and Crossbones. See if we can check it out.
Skull and Crossbones, okay.
Yeah. Are you familiar with it?
I remember asking if it was near the Jolly Roger.
That's right. Oh.
I vaguely remember that, but I don't remember that star exactly.
You can see over here that the telescope is just slightly impinging on the dome. So this tells me my limitation right there. Not a problem, because what I'm doing is the software I'm writing is actually, it's going to move the dome to wherever the telescope is. So I won't have to worry about pointing the dome. It's going to do it by itself. That's the whole idea. That's the thing that's important. Is you're going to automate as much as you can. Okay, so now let's do a discovery photo, 20 seconds. And because it's discovery, I'm going to pump it up here. 20 seconds, 10,000. Off we go into the wild black yonder. Okay. The idea is to try and find the Skull and Crossbones Nebula. I don't know if anyone saw the Skull and Crossbones that I had uploaded some weeks ago. Yeah, it's stream. Okay, so let's see here. Okay. And I want to process a little, so that's not. It doesn't appear I have the dome in there, but it does look like I've got some kind of light issue from wherever. Yeah. Hard to see it now tonight because of this, but there's plenty of stars, that's for sure. Let's see, let's go back to our other guy here. And let's...
I don't know, unless it went directly to the star, I would never be able to figure one from another.
Oh, that's true. Like if we, let's see. We can go here to this little tiny cluster, which will give us a little more leeway and flexibility. Okay. And off we go.
And best of luck to Rabbit. Hide some aces up your sleeve. Poker game's about to start.
Oh, all right, Rabbit. Wascally Rabbit. Very good. Okay, so let's do 20 seconds for 10,000 here. That's a lot. It's a lot for the cluster. But it's okay. Yeah. Zoom out for now. You can see this cluster, and I gotta get us a little bit. I gotta check to see if there's clouds out there, because this is looking too bright. Yeah. See the color modeling in here? This is point is, I see this modeling in the color. Typically, that's water vapor. So I gotta I've got to go make sure. So if you
Okay.
don't mind, I will.
You don't mind if I plug my own stuff, do you?
No, I don't at all.
Okay.
And I shall return. So take over, Amanda. I shall be right back.
Huh? Okay, you heard it. It's time to plug. Well, like I said earlier in the show, unfortunately, there will be no live Sky Tour Radio this Sunday. Sunday at 8 p.m. Eastern on KGRA Radio. It's now a 2-hour show. We're starting an hour early, so check that out. The Super Bowl is on, so it will be a replay this weekend, but next Sunday will be all new. As for this weekend on Radio, tonight, check out Bill Skywatcher. He's doing the Skywatcher Midnight Metal Madness show. I think it's about 3 hours. Starts at midnight Eastern on Radio. I will drop the link in chat so you guys can all check it out. It's a great time. Well, anyone that's ever heard Bill on the radio knows he's an absolute natural, and he's having a good time, and so is the chat room, so please come and check it out. Sundays, also, our good friend Johnny Unitas, who is here in the chat, is going to be playing Sundays with Sinatra. A bit of easy listening music on a Sunday if people are recuperating and trying to make it through the rest of the weekend. That's going to be starting at noon Eastern on Sundays, and then Sunday nights at 10:30 Eastern p.m. Sunday Night Funnies are also appearing on Radio. And that's just the weekend. Lots of great shows going on during the week. Johnny also has the show. It's a music mix. We don't have an official title yet. I'm thinking like Music Unitas or something. But Johnny is the host there. Wednesdays at 8 p.m. Eastern. So do check it out. It's Radio. There's a chat room. Sign up is free. It's not too difficult getting in. I managed to get in, so I think you just have to check a email or something. So look to all the great programming going on at Radio. I hear Mark coming back. Yeah, Laura, exactly, like the Headbangers Ball. That's what Bill is kind of modeling off of. And I remember listening to the Sunday Night Funnies on Q107 back in Toronto when I was younger, so it was always a good night, good way to end the night, so... I'm also starting a new show Tuesdays. It is Tuesday at 10 p.m. Eastern. It's sometimes album listening parties or a featured artist. Then Johnny at 8 p.m. Eastern on Wednesdays. We may be having some conversations happening on Thursday nights from now on. Not sure the details on that. A lot in the works for Radio. Charles may be joining Ronald sometimes. Ronald is the station founder. He might be having Twin Crow on for some readings. Trying to think. You can always hear Ronald from 10 to noon, Monday through Saturday, AM, Eastern. He plays a great variety of music as well, different artists, different albums, and keeps you moving through the mornings. So be sure to check him out. Are you back?
I am.
What's going on outside? Clouds?
A few, and I'm just I'm moving us to a place where we don't have to worry about them for a minute.
Yay!
Yeah, little, hey, you gotta be flexible about these things. If you don't have flexibility, you're out of luck. And I think we're gonna have some fun up here.
Oh, I like this one.
The song or the object?
Yeah.
Okay. Okay, so we're moving up. See the stars whipping by at high speed. It's pretty clear what this is based on fact that I showed it to you inside the program there. Okay, now let me look at this for a sec. This is indeed the Pleiades. This is Alcyone. Okay, this is Maya. This is Merope. These stars have they're sort of, this is the centerpiece because there's 4 stars right near each other here, and these stars have nebula that are associated with them. Let's go check it out. 20 seconds at 12,500, 800, and off we go. And if you look here, you'll see that we're actually looking right out of the dome here. So I've moved the dome. You guys have no idea. I cannot wait to implement that auto moving system that will just move the dome properly.
Any ETA on that?
Not yet. I'd like to say tomorrow, but yeah, it's not ready. Yeah, we're getting some strange reflections here. These reflections are not normal for the Maya. We're supposed to see the Maya Nebula only, which is right here. Clearly, there's some more going on the weather-wise out there. And this is all but faded. This is supposed to be much more combed look. It's not. So we gotta figure out why that looks that way. But we don't have to. We're just having fun looking at stuff. I'm not gonna try to make any records tonight. This is good. Try this. Hey, Dee Dee.
We have a question here from Laura. Are you ready?
Yeah.
Okay. Do you have any thoughts about the Sail Lake object astronomers are tracking recently 600 miles out? Do you know what she means? A Sail Lake object. Astronomers are recently tracking 600 miles out.
I don't know if I might not. I feel bad that I don't know what she's talking about. You know what though? I might be able to figure that out. Because I know that that astronomers are tracking. I'm gonna just write up a note here and try and find out. Because yeah, that's what I was gonna say. I know that it was like there was a theory that Oumuamua was this interstellar sail that was created. You know what? It was 10 times longer than it was wide. However, Oumuamua was also not really seen. We didn't really actually get a photo. We didn't check it out. We only inferred its shape because of the way it was moving and its speed. So it could have been something much more definitively constructed. It could have been something else. Most likely it was a spindle asteroid because you don't just go leap to something like, extraterrestrial spacecraft, without good, proper vetting of the data. But I think we were talking about, it was a Oumuamua that they thought might have been a solar sail. And that's, but again, I don't think it was. I think it was just an ordinary asteroid. If you've got any, Laura, if you've got something else that you're thinking about, or if there's something else that you want to help me out with that, where the story originated from, and I can find it and figure it out.
Yeah, I think that's what they're saying. I think it might be a piece of an Oumuamua, possibly.
Yeah. The 600 miles is what threw me, because Oumuamua wasn't ever 600 miles from us. So, yeah, okay. Oumuamua, Hawaiian for like messenger, was
I believe.
It was a real interesting asteroid, because it was the first time we saw an asteroid shaped like a needle, basically. And it was a true extraterrestrial asteroid. We did not have this asteroid form in our solar system. But then again, we had no idea whether the thing was, an actual asteroid or not. In the end, I mean, it certainly probably was. As I said, certainly probably was. Okay, now there's our Pleiades. And now let's see. This is the star Alcyone that I told you about. We have Merope here, and we have Maya. And tonight it's actually looking a little bit rough in the Pleiades. The sky is not as clear as we'd like it to be. It's okay. We can't look at the California Nebula. Try this one. Never looked at this one before. Be interesting. This one is supposedly like the Trifid Nebula that we see in the summer, but it's called the Northern Trifid Nebula. We can check it out. I don't know if we'll see it. Here we go. Laura, I'll check it out. I'll go looking.
I think she said she was looking for an article. I'll let you know if it comes in.
Yeah, thank you. If she does put in a link.
Oh, here we go.
It's a video. Oh. Okay.
It came right up in my pop-up. Weird.
Yeah.
Oh, no, it didn't. It opened a new Facebook chat.
Yeah, that's a secure team.
Okay, I'll have to look for it later. It's Secure Team?
Yeah. Laura, Secure Team 10 is a group that is not as trustworthy. And I mean, they did a story on me, and although they got it absolutely correct, they were fair to me, but they're not always fair. So I wouldn't
bank on Secure Team 10, actually. Most people don't.
Nor would I. That's just my opinion.
That's a good opinion. This one might be
They view it with a grain of salt, guys.
Yeah, that's true. View it with a grain of salt. A lot of salt. Rock salt. Okay, taking a picture, 20 seconds at 12,800 of this object known as the Northern Trifid Nebula. There it is. There it is. That's interesting.
What are we looking at?
It's a little nebula that is just north of the Pleiades.
Called?
The Little Trifid Nebula.
Oh, the Trifid.
A little, no, it's not the Trifid.
Oh, the Little Trifid.
Well, it's actually called the Northern Trifid.
Oh.
Because I guess the other one belongs to the south. And this one is it's a little bit trailed, so I'm going to have to redo it. But let me check the one that came before it. Yeah, that's also done. Okay. I thought it would be trailed because the telescope control program hadn't released control yet. So I'm doing one now without that. I hope you guys are enjoying this. I'm enjoying your company.
I think we all enjoy seeing the beauties of the universe.
Yeah. I sure do.
Tell us the story of this nebula. Who discovered it and how and when? Beauties of the universe.
You mean this nebula here?
Yeah.
Alright, well let me see if I can. I've never looked at this before.
Oh. What made you want to look at it tonight?
I don't know, because it's always been there. I've always wanted to see it, and I never had looked at it before, which is kind of cool.
Very cool.
Yeah. Laura's asking, is it fake? I think meaning the Secure Team 10 video.
Yeah, that was...
Sometimes, yeah, they do things that are fake, but sometimes they don't. But the idea is that it's hard to trust them. You know, that's the only problem. So I can't say for this, but they will take the smallest nugget of truth and turn it into, you know, what they think is absolute truth, and it's not necessarily true. Kind of a bad combo of events. All right, let's see here. Now you can see with little processing, you can see why they call it the Northern Trifid. I'm sorry, yeah, because you've got
You got a lobe here. It seems to be split in 3 ways. See this? That's why that's cut that way. Let's see if we can get some details about this, though. Let's go and...
I didn't mean to put you on the spot. I'm more interested in the stories behind things than details about...
No, that's okay. I don't...
Well, because I don't understand the chemistry yet, so a lot of the time when you're talking about, like, you know, what it's made of and what it's doing, and...
Yeah.
And I have no concept when it comes to distance, so I mean...
Well...
100 light years, a million light years, I don't know.
Well, this is like 6,500 light years.
Yeah.
This object. And it's actually, like I said, it's distant. It's in a different arm of the galaxy, a different spiral arm. And that's pretty cool that, you know, things
So
are...
if they're all spiral arms, can we see to the center of each spiral in each arm? Or how many arms can we see? How many arms are there?
Well, that's the thing. See, we don't have the ability. You know, we've got there's about 7 or 8 different arms
That we know of.
in our galaxy. Yeah, you know, I have an image that I gotta, well, it'll take me more time to dig it up and locate it and pop it up. But it shows all the spiral arms in the galaxy, and you got the Norma
One's
arm.
called Norma.
We got the Centaurus arm. We got the Perseus arm. We got the Orion Spur. We have the Sagittarius arm. We have the Perseus arm. You know, we have, and we're actually in the Orion Spur. So we have plenty of spiral arms we've named, but the fact is we don't have we didn't have actually a true vision of our galaxy for a long time. Our galaxy, we used to think of it as a spiral galaxy. In the beginning, we thought it was a fairly tightly wound spiral galaxy. And spiral galaxies the nomenclature is given as very tightly wound as an S0. Then there's an SA, a B, and a C. So SA, SB, and SC with looser and looser arms as you get higher. Like SCs are fairly loose.
We talked about this one night on
We
Sky
did.
Tour Radio. I remember seeing the pictures.
Yeah, we did.
Yeah.
It was. We talked about the Hubble tuning fork diagram, which was the diagram used to differentiate between the different types of galaxies. S0 was in the middle of the notch, and it would split off, and you could end up having an SA, an SB, and an SC. Now, we used to think that we were an SB, okay? But off of the S0 is another branch, which is the SBA, SBB, and SBC. What's that B stand for? It stands for barred spiral. What's that? That means there's an extra bar of stars down the center, and the spiral arms come off of those, sort of an offset. And that barred spiral versus spiral was something we didn't even think we didn't think we were a barred spiral. Turns out we are, and we might be like an SBC, which is a fairly loosely wound set of spiral arms with of the barred spiral type. And that could be us. It's very likely that that's us, as a matter of fact. So that's kind of interesting to me, you know. So I'm taking another picture of this object. I'm gonna take a few and I'll stack them for you, and put them up on SkyTour livestream for you. That's the SkyTour livestream Facebook companion site that goes with SkyTour livestream.
And I will get a link. But, so, you're saying we can't see to the center of any spiral?
Well, the center of each spiral arm, meaning where the root, where it starts? Is that what you mean, like the center of the galaxy?
No.
Okay.
I mean, if we're looking into a different spiral arm of the galaxy, can we see into the center of it? Like all those spiral arms you mentioned, can we see into the center of all of them?
Oh, I see what you mean.
Yeah.
Well, yeah. For some, yes. Some, no. I mean, farther away from the center of the galaxy, we can see through them. But toward the center of the galaxy, there's a lot of obscuring dust that gets in the way, and we can't. See? So we can only see through them when we're looking in a direction that's sort of kind of away from the center of the galaxy, looking more toward the thinner cross sections, because there's a lot of dark nebula. I mean, look at the Orion Nebula, that image we took before, just that Orion Nebula. Okay, if we just go back and look for that, give you an idea of what I was talking about. Okay, we look at this. You look at this, you can clearly see, right, that this is dark obscuring dust here, okay, that was in the Orion Nebula. And it was before I got so rudely interrupted. So this is dark obscuring dust, and it's all out in here. It's all throughout here. This is an area that's being blown open by these powerful stars in here that are causing the ionization and the reflection going on in here. So see, this is otherwise a very, it's an area full of dust. Okay? See, here's more here. This stuff is actually obscuring the brightness of the nebula behind it. This is obscuring the brightness of the nebula behind it, sitting in front of it. Follow? So this is definitely something that we have to think about. So when we're looking toward another spiral arm, say, in our galaxy, we have to keep in mind that, we're looking through a lot of that dust. And
yeah, that's what I was wondering, if anything could penetrate all that. No.
Well, truly, we can use the infrared telescopes, and they can see into it to some degree, but we can only see into it as far in as radiation can escape from it. Because if the radiation can't escape from it, then it's just going to be an opaque shield to us. So, this is going to be a pretty picture, guys, this one. I'm just going to take a bunch of these just to have them set up. This is the Northern Trifid Nebula. Yeah, see what Daryl wrote in there? And when we look towards Cygnus and Deneb in the summer, we're looking 90 degrees from the center of the galaxy. Okay, and we're looking across to the next spiral arm over. When you're looking at Orion, okay, you're looking toward the next spiral arm that's toward the center of the galaxy, because we're actually on the edge of that. But if you look toward Perseus, we're looking at the spiral arm that is on the outside of us, looking away from the center of the galaxy. It's diametrically opposed to the actual direction of the center of the galaxy when you look at Perseus. That is where Cassiopeia is in the double cluster. So it's really a very interesting 3D structure that you have to understand that you're living within. It's a very fascinating thing. Yeah, it's beautiful. Chris Elliott from Elliott Astroimaging has joined us. Hey, Chris. Welcome.
Yeah, he was in here earlier.
Was he?
You can check out his work at Elliott Astroimaging here on Facebook. He does some great photo imaging as well.
Yes, he does. He and I have different styles. We're doing it differently, which is wonderful. I prefer to be doing it differently because that way it's great. I mean, Paul and Keith, Planets in the Moon, Bill New York Skywatcher, wide-angle meteor showers in the Skywatch. Sky Tour live stream, deep sky objects. Individualized attention on each and every object. which is kind of cool. I think that's just probably the right way to go. Because after all, I mean, that's what I know. I know about those things, so why not? Why not bring them out? Why not discuss them? If any of you have any questions, let me know. I'm just whipping back and forth here to get these images done. Stream shows healthy. Once again, in the object we're looking at, you can see there's a central star in here, and then there's a dark nebula here, a dark nebula here, and a little bit of dark nebula here, making these three reasonably bright lobes here. Thus, this is the Northern Trifid Nebula. Kind of cool. Chris, man, you need to get your telescope out.
Chris just bought a house, actually. He's in the process of selling the one he's in now.
Mm-hmm. That's fantastic.
It is. Oh, yeah, that was going around this afternoon. Did you hear about the meteorite that exploded over western Cuba?
Yeah, we have a number of those each night that can occur. Some nights none, some nights multiple. Thing is, when they explode, when they do these explosions over populated areas, that's when we hear about them. We don't hear about the ones that explode over the Atlantic and the Pacific, the Indian Ocean, Antarctic Ocean, North Sea. We don't hear about those because those aren't seen by anyone. But I will tell you this. There have been cases where in Nova Scotia, where you are, Amanda,
Mm-hmm.
and in England,
Yay!
people have heard explosions that were caused by the same object. Think about that.
Wow.
Over in Nova Scotia, somebody hears a big rumbling boom. And then approximately the same time, on the other side of the ocean,
Across the pond.
yeah, they hear boom. And what is that? Well, that's when the shock wave from the meteor that exploded over the North Atlantic reached the other side. That is Nova Scotia on one side, England on the other. And that accounts for a lot of these strange explosions that people hear. But there is also what are called earth noises. There's the noise of the earth, doing its daily business. And when you hear these earth noises, they can be unnerving because it's sort of weird hearing molten magma flowing beneath your feet. It makes strange sounds. And submarines can hear these sounds, and they're classified as geologic sounds, but they are oddball sounds. Sometimes it sounds like not creaking, but like kind of like almost like the earth talking. It's a really strange thing, you know. But I had here some strange sounds started happening around here. And it could be Dee Dee. I'm getting to that actually, Dee Dee. Then around here there were some sounds where late at night, like 2 or 3 in the morning, I could go outside and I hear this hum, this unnatural hum. Now there's really no natural hums, let's be clear. So I'm thinking, okay, has to be some type of unit of some kind being run. But driving all around, I can't find the source of this hum. Wherever I go, it's always just that much farther away in the other direction. So I go the other direction, and it's that much farther away in another direction. And I did that like 2 in the morning. I drove around to like 3:30, trying to find this. I was determined. I had to have the answer, you see. And what did I get? I got tired, is what I got. Because I didn't get my answer. I didn't know what it was. And then that happened for several days. And as soon as it had come, it had gone. Never to recur. Really odd. I know that wind sometimes induces these strange resonances in little valley forms and so forth. And you can get this valley causing some kind of weird bellowing, like it's actually talking, like it's bellowing, like you know. Well, then there's the other things, like hearing these trumpeting sounds from the sky, and that harkens back to you know, some religious groups that say you're going to hear the trumpet sounding, and then you know God is coming back and so forth. The fact is that those trumpets actually have been shown 9 times out of 10 to be hoaxed. In fact, I caught one where the trumpeting sound was like and it echoed, and I thought, that's interesting. That sounds just like the War of the Worlds movie with Tom Cruise, you know, which was filmed right nearby here, by the way. They made it in Naugatuck, Connecticut, just like 10 minutes from me. And when those Martian machines did that sounding, that, you know, it was a sound which filled, you know, when Hunter was smaller, he was actually scared of that sound. When he heard it, he couldn't watch the movie. It frightened him. So it got a visceral reaction it was supposed to. But the trumpet sound was actually then, of course, seized upon for hoaxes. And they took that trumpeting sound and made that something they played softly interspersed with regular city noise. It made it sound like this was happening in the sky. Listen to this, and you hear it. Well, clearly it was from War of the Worlds. They were just trying to hoax people. I haven't heard any trumpeting sounds that are other than hoaxes coming from the sky, frankly. But that's just me. You know. Yeah.
Are you on the ley line?
I don't know. I actually don't know. I don't know whether I'm on a ley line of any kind. Ley line being that a line of energy that has been identified in the past. I don't think I'm on one of those. Hey. Thanks, Keith. My voice is a little bit better, yeah. Thank you. I'm photographing the Northern Trifid Nebula here, Keith. Thanks for stopping in, man. Benny Loco, thanks for coming in. I want to thank you for dropping by. So we have Benny Local, we have DDB, we have you, Amanda, we have Chris Elliott, we have Ronald from Earth, James Dugan from Down Under, Johnny Unitas, Laura Newbert, P&K Science, otherwise known as Keith from P&K Science, formerly P&K Space Imaging. And we have Raymond B, and then we have me. So that's who we've got participating right now. But I'm sure there's more that could be if they just so chose to. It's one of those crazy nights, isn't it? You know? And there's 45 of you watching, so I'm sure there's a few of you out there that could participate in the chat if you want to. You don't have to. You know, we're having a ball anyway, showing you the sights. I'm taking the photos of something called the Northern Trifid, and this is what it looks like now. This is what I took a picture of now. This is what we're seeing here. Okay, and give you an idea with a little bit of just instant processing. Okay, it kind of looks like this, maybe a little bit. It'll be a little bit cleaner than that. I'll give you an idea. Let me just try and come in here and brighten it up a bit, give us a different shading. There, I'm getting rid of the noise. Okay, so there we go. So it kind of has this look to it, and it has this interesting shape to it. And we're going to actually check it out once I'm going to do the stacking process with it, and then try and bring it out in more detail to show you. All right, and that's what I'm doing right now. So I'm taking a bunch of those, and as you can see, our telescope is doing well. It's pointing where it ought to point, you know, out of the slot. This camera is riding on the telescope, so we can actually see the curvature of the telescope here as it's riding along. This other one is showing you right where it's pointing. Not bad. Not bad. Alright, so we're going to go back and just do a few more of these, and then we'll take care of looking at some other things. Sorry about my voice. I have to just... now and then I just have to be quiet to give it a moment. Amazing to think that these things are just sitting out here, and no one will ever see them unless someone comes along and says, "Hey, look at that thing," you know. So I think that's kind of cool, you know. I've always seen the beauty of the universe. I've always seen the universe as an amazing concoction of chemistry, and it's just impressive that we're actually here as these physical beings based on a smattering of atoms delivered by stellar nuclear furnaces. Just incredible to me. Okay, 3 more of this one, and then we're done. Then we can figure out another place to go. Okay, so the California Nebula is very extensive, but I think we're going to go there next, which I'll show you. Okay, this is second to the last. All right, and just do one more, and then we'd be done with it. Okay.
What?
What?
Saw that.
What, raising up the music?
Mm-hmm.
Oh, yeah. Okay, this is the last one here. This is the last of the Northern Trifid. Now we're going to go on to a new object, which I think you will find interesting if it's actually showing well tonight.
What could it be? What could it be?
Yeah, exactly. Well, people are looking at it now. They can see what it could be. So let's go see, shall we?
I can't see that small away. Something nebula. Wait, crystal ball nebula?
Yes.
Is that what it says?
Yes.
Very cool. I don't remember this one.
Because we haven't ever seen it.
Ooh, you. Oh, you. Oh, speaking of. Oh, wow, it's totally
What's
off
that?
focus, but
Oh, go ahead.
congratulations to Supernatural. Just got renewed for season 15. Yay!
Mm-hmm.
Crystal ball, witches, Supernatural. You know how it all goes.
Oh, that's the connection. Okay. I was wondering. I didn't know. 20 seconds to 12,800. Let's see what we get here. Okay, 20 seconds, 12,800 ISO. Keith, you're talking about bringing in your P&K Science Infrared Service System. What does that stand for? He'll hear me and he'll respond.
Well, the last S can't stand for stamp system. It says system.
What? What's that?
The last S can't stand for system because he said system after that.
Oh. Okay. So here you see the Crystal Ball Nebula. If you notice, this planetary is very interesting, isn't it? Let's do something here. Let's actually
P&K infrared sky scan
okay.
system.
Very good. Wow, this is a really pretty nebula. Look at that. It's sort of robin's egg blue. See that? Robin's egg blue color. That's pretty. I'll do a few of those. I'll just recenter it. And then let's do this. And
I wonder what it's going to look like when you take a closer picture. Is it going to look like the ring, or is it going to be more solid, like an actual robin's egg? But it looked kind of ringy to me.
It did look kind of ringy. To use an Amandan term. Right.
It is.
Yeah, it's an Amandan. It's an Amandan term. That's fine. I don't mind your terms.
I like Amandaism better.
Yeah, that's sort of a cumbersome word, though.
I know, but you have bunkerisms and Rickyisms.
Yeah, but it's a Gervaisian type comment, not a Gervaisism, you know.
Yeah, but he ends with a consonant and I end with a vowel.
Really? Since when? Oh, okay, well, Amanda, that's correct. It could be a currentism. Currentism sounds better.
Currentism?
Yeah. This is beautiful. Let's look at this guy a little bit more. Let's check him out. Okay, so this is a nebula that's actually about 2,500 light years away, and it's a planetary nebula. So clearly, we're looking at this beautiful glow, and this beautiful glow we're seeing, of course, is the oxygen 3, the doubly ionized oxygen that I told you about earlier.
Where's your water?
I Don't have it, but have this.
Chug.
I had water before. I actually had orange juice. I've been drinking orange juice.
Oh, good. Good for you.
Yeah, I drink a lot of orange juice. Okay, so you can see
the citrus doesn't hurt your throat from coughing so much, does it?
No, it actually doesn't.
Good.
I use crushed ice, and my refrigerator gives me crushed ice too, so it's really nice to be able to get that crushed ice along with the orange juice. It's just a flavor you just can't say no to. It's just so good. It's so good. I gotta have more of that stuff. It's so good. Indeed. Yeah, Daryl, there might be. Daryl's asking, is there a notch in the lower part? And there, well, of course, this picture has a little tracking error, but there seems to be. If anything, actually, this picture with the error shows a lower density area here, which is actually easier to see because it trailed a little bit. So yeah, I think you're right, Daryl. I do believe that there is either a notch or it's actually a dark nebula. And what that means is the star we see is actually a white dwarf. Amazing, isn't it? How white dwarfs, even from 2,500 light years away, are still bright enough to be seen in the telescope. Really, really something else, I'll tell you that. Yeah, that's really pretty. Again, dynamic noise reduction, getting rid of noise. I think that's a really interesting capability, is to just get rid of that noise right up front. Oh, Chris, you can't stop streaming just because you're buying a house. What the heck's wrong with you? Don't you know?
He says he'll be streaming, just not as frequently.
I read that, yeah. That's why I'm saying. Yeah. Don't you know you're supposed to stream and not stop? Hey, when this is all being moved to Arizona, I'm going to be streaming. Actually, one of the things I'm doing, and I haven't decided the best approach yet, but I think what I'm going to do is I might make the observatory a portable observatory so that I can take this type of imaging quality on the road anywhere. I was talking to Keith from B&K. He likes the idea. So we might make up a consortium of folks to actually do this. If Laura, you're still out there, take note. I think we've talked about this. I want to actually build a trailer that actually has an observatory in it. A remote system. It's not going to be something you get in. And then we would tow it, or we would have it delivered, by a freighting company or something. And wherever it goes, it gets set up for a period of, say, 2 weeks, somewhere in the country, and goes fully remote. And I'd like to do that. And that's the attractant. That's the attractant that will bring, like moths to a flame. It's going to bring people out to see this thing and to be part of it. I'm looking forward to that. I really think it's going to be a very good possibility. Have to work out some logistics, but I think we might be able to pull that off. I have a design already for a self-leveling trailer so that whoever delivers it, all they have to do is maybe push a button and it'll take care of everything. That's the trick, but we can do it because we can actually, if we can connect to it, we can do all this stuff remotely. Align it remotely, the whole 9 yards. I'm looking forward to that. I am. Okay, my battery outside is, even though it's been charging through the entire time, it's being drained, of course, by the cold. So I have 13% left in this battery. And I think maybe when this battery goes, we'll call it. But is it?
if you started at 8:30, it's about 2.5 hours now, but then we had some buffering issues and lost signal for a minute, so...
Yeah.
Almost 2.5 hours, not bad.
Okay, well, maybe I'll just change the
Well,
battery.
considering you usually say you're going to aim for 2 hours and 5 hours later.
Yeah.
So 2.5 hours is a pretty short one. Still a good standard length, but your time, it's not bad.
Yeah.
Oh, and Keith is just asking.
Keith, I'm not sure. I'm
The battery goes, I guess.
Yeah, we're actually, right now I'm thinking I got about, batteries at 13%. But that could hold like that for another half hour, too. It depends, because the camera, it's pretty amazing. Because right now
I've really been conserving battery life lately.
Well, consider this. I didn't start streaming until about 7:30, okay? But the camera,
sorry. 8:30 my time, yeah, 7:30
Yeah.
yours, yeah, sorry.
But consider that I had the camera in the observatory and up and running at 5:30. So it's been up and running and just sitting idle since about 5:30. So if you look at the time now, I mean, we're looking at, easily another 4 hours that it's been sitting there. And normally the battery lasts, in a cold like this, 45 minutes without a trickle charging. And we kind of increased its battery life tremendously because it's getting a slow trickle charge. So the battery's being drained slightly more than it's being charged. But still. Okay. All right, Keith. That's not a worry. I can't wait to start going through that. Have you told everybody what we're doing, Keith? I don't want to say it unless you have already made it very clear. I think you did on the stream, but you'll
I think I'm missing something. I want to be filled in.
Yeah, I'm going to fill you in. I think
everyone wants to be filled in.
I know.
Sorry, you know me. I gotta be the voice of the people. That's what I'm here for, to get questions and
that's fine.
requests and...
But I just know better than to just, blurt something out without... Okay. See that? So Keith's comment was, nope, we didn't talk about it. I'm just going to drop it on everyone out of nowhere. So that's it. So I'm not going to spoil his surprise. That's what it is. It's a surprise. We're not keeping anything from you. Why? Because we're doing it for you. We're doing it for all of you. It's sort of a cool little thing. It's like knowing you're getting a present on Christmas, but we're not going to tell you what it is. You're not mad at us because we're not telling you, are you? Just
Hannah might be getting her own telescope. How exciting. I didn't know that.
Yeah, you know why? I'll tell you why. Because she's
people like you.
She's so absolutely enamored with the night sky, like many people are. And sometimes they just need that little extra push to bite the bullet and say, I want a telescope. Yeah. And I think that's...
And you and Paul and Keith and Bill and Chris Elliott and people like that. She's attributing you with the reason why you're the push that she needed.
That's it. I am happy that she's doing it.
And for people that are actually considering getting telescopes, you can go back and check various shows here on the live stream or in SkyTour Radio. Actually, we had a show just before Christmas called So You Think You Want a Telescope for Christmas. So
that's correct.
You can go and listen for a few pros and cons, might help you on your way to purchasing. So
yeah. And if you also have questions that you'd like to just, levy right here in the chats, feel free. There's no bad questions, and you can never not ask me anything. I always make myself available to folks.
That's very true.
I mean, you know what? The bottom line is, there wasn't anyone there for me when I was a kid. I had to learn all these things. And sometimes, left to my own, I learned things wrong. And then I had to undo stuff to learn it right. So, and make mistakes. And that was kind of tough. I don't want to make mistakes. But, you do. It's part of, maturing as you're doing these things. Okay, this is the last photo, and then we're going to go and see what else we can see before we lose our battery, Captain. There's a lot of these small objects here that you just don't know are there, see? And that's what I like about them. See? Here's the Pleiades. Okay, the Seven Sisters right here. Okay, we're familiar with them. But if you go a little bit more this way, okay, which is kind of east and toward the top of the sky, so the zenith, that's where the crystal ball is, the thing we're taking a picture of now. What's the Per Cloud? I have never heard of that. That's crazy. Wow. Excuse me.
Something you've never heard of?
Yeah, well, you know what? If you can imagine, that's like giving me the name of a star and me saying, I've never heard of that name. Very likely. That's a very likely outcome.
Let's go see it. Where are you going?
Oh, well, I don't know if we can see it, but I can try.
What was it? Tell us all about it.
I don't know anything about it because I've never heard of it before.
What's its name?
It's this little thing right here, which I can't.
Oh my god, you're gonna make me squint. Oh, are those a bunch of numbers and letters?
Yes.
Okay, I'm not squinting.
Okay.
At least if it was like a word, I had a chance of, figuring out what the letters were and maybe what the word might be.
Yeah.
If it's a bunch of letters and numbers, it's going to be too small on the screen for me. I saw it too in an E.
Yeah. Jello, no problem. Okay, so I suppose my telescope will come back here and tell me that this is going to be settled down. And there it is. And now I'll just take a picture and see what we get. See if we can actually see. There's some nebulosity, nebulous cloudy detail that's associated with some of these stars. All right, Jello, see you later. And so let's see if we can see it. We may or may not. I'm going to tell you this. Wait until... Oh, I got a little bit of dome impingement. You can actually see it over here. You see over here, the dome is actually... in the way of the telescope here. Alright. That's what I get. You can also tell by the shape of this star image. See that really sharp line right there? That sharp line indicates a break, a harsh break to the starlight, and that usually means that you've got something in the way. Otherwise, the starlight is even all the way around. Okay. So anyway, this one is not going to work. Let's go back to our nice view here. All right, and let's see. I can't do that one either because it's going to be even more in the way. So I have to go to the left somewhat to see it. That is unless I want to go out and move the dome. But if I do that, I'm going to change the battery. And if I do that, I'm going to stay out here for another 2 hours. I'm at 10%.
Let's stick with things you can actually see.
Well, for now.
Yeah.
For now. Okay, let's see here. I just love cruising around. There's some areas too, by the way, which are really cool. Like here.
D wants to know, D Smith, I should say, wants to know what's in the way causing that break. What could be in the way? Are we talking like an exoplanet?
No. I'll show you in a sec. I'm going to actually, if you, I'll do it now because when I move this, you're not gonna see it. So here we are overlooking the dome cams. If you look in this dome cam, you'll see the telescope is pointing up in the sky. Okay, but if you look down at this dome cam, you'll see that I'll show you right here. You'll see that the actual dome is right here, and the telescope is also right here. So part of the telescope is now impinging on the edge of the dome. So we're getting some of the dome in the view right now. So that's that. But you know what I'm going to do? I'm going to take this picture of the Hyades what are the Hyades? Well, the Hyades are a cluster of stars that are associated with Aldebaran, okay, in Taurus the Bull. Okay, and Aldebaran is here, and the Hyades.
Bull? Taurus the Bull?
Yes. Yep, and so I'm just going to take a picture of.
And what's the Hyades?
The Hyades is a cluster of stars that's in.
Behind the eye or in the eye?
It has part of it.
Part of it.
Yeah. So what I'm going to do is this. I'm going to make sure the telescope is over here when I do this. So we're going over there now. And moving. And we're going to come up on the Hyades here. And you'll notice it kind of... It has sort of a... it's an interesting look, right? You can actually see some really interesting things. If I move a little bit eastward, okay, and we look at this, we say, well, look, there's a few stars, right? However, let's do 20 seconds at 12,800 and see how many stars there actually are.
I was so excited to see Tony. I was tripping all over the letters on the keyboard trying to say hi.
Tony the Night Owl?
Tony the Night Owl, indeed.
Welcome, Tony. Thanks for coming out to hang with us. So look at this. Here we can see, and we're looking at these beautiful stars. And I'm just going to give us a little bit of an image processing edge here. And that's beautiful. This is a really pretty area. You can see how bright these stars are. They're very, very clear. You can see them with your eye when you look up in the sky. You can't see these though, but they're all there. And we've done this before, and I'll do this one more time before going out. At 9%, I'm going to bring up my camera control. I'm going to turn off the tracking now. Okay. And now that it's drifting, I'm going to take another 20-second photo. All right. So now I'm taking a 20-second photo of these stars, and you'll notice they're moving across the screen. Okay, and when it comes up, you'll see the trail. And here's what's important about that trail. First thing first, I'm going to start tracking again. Okay. You'll see this is interesting because this shows us a couple of things, and I'm doing this sort of in a processed view, okay, because I want you to see how this looks. You can see the different colors of the stars very clearly when they're drawn out like this, and that's pretty cool. See, that's one way to see star colors, is to take a long trail like this. This is something you could do with a telephoto and a tripod. Okay. However, right now, excuse me, I am going to go out and change my battery. All right, and give me a moment to do that, and then I shall return because I don't know when to quit. So, Amanda, if you don't mind taking over, I will actually leave you guys with one thing here before I do that. I'm going to take us up and
11 here.
Huh?
It's 11:11 here.
Is that a bad thing?
No, make a wish.
Oh. I wish I could continue longer. Huh?
What?
I wish I could continue to do this for a longer amount of time. Hey, I'm gonna get my wish.
Are you changing the battery out there too?
Yes.
Oh my god.
But only because D. Smith asked me to. See, I listen to chat. Okay, so what do we got going on here? Alright, I got my telescope back here. Got it back, and now I'll just do a 20-second here. See what I get, and then I'll go out and change the battery. So for the next couple of minutes, I may move the dome too. For the next couple of minutes, it's all you, Amanda, okay?
Okay.
Alright. Yeah. Not quite yet.
I think I plugged every show on Nerd Radio so far, so
That's okay.
I don't know what to say.
Teach him some astronomy.
I don't know any astronomy.
This is beautiful. Look at this Aldebaran and some of the brighter Hyades down here.
When you get back, is there any chance we can see Vega? That really turned
No.
Tana around and got her thinking of getting a telescope, so...
No, Vega's on the other side of the planet right now.
Oh.
Exactly opposite side of the sky right now. That's okay.
Okay.
All right.
Okay, yeah, go do what you're gonna do.
All right, I shall return. I'm going to leave you to live view in case something shows up. All right, so here we are. This is the live view. And I'll leave it like this. I won't bring up the telescope control so you can see it. I'll be right back.
So, while he's away, I don't really know the night sky as well as some other people here in chat, but if you guys do have any requests on things you want to see, if you know what's up, or even if you don't know what's up, doesn't matter, I'll still ask on your behalf. Anything in particular you guys want to see, let me know. Of course, if you have any questions for Mark, you can also post that in the chat. I'm DannyFan1 in chat. I'm Amanda, and I am reading chat as it goes by, so any questions or requests, just type it in there and we will get to it. I'm in the Atlantic time zone. I'm up in Nova Scotia, Canada, so that's why it's an hour earlier for me than it is Mark. Mark is in the Eastern time zone. He is in Connecticut. That's where the telescope is being shot from. That didn't make sense, sorry. That's where the telescope is. That's where the views are being taken. In less than 2 hours, our good friend Bill Skywatcher goes on live. That's Earth Radio. Let me see, I'll get the link again. It's going to be 3 hours of metal and fun. Earth Radio. It is free. It's always a great group of people to talk to. I'm gonna do my best to be there the entire 3 hours. It starts for me at 1 a.m., but it is midnight Eastern, hence the name Midnight Metal Madness with the Skywatcher. So, if anyone's ever dropped by when he's been gaming, you've heard some of the music he plays. It's not all heavy metal, a lot of it is, but a lot of it's classic rock and, you know, some, maybe some of the roots of rock and roll, roots of heavy metal. It's a good show. His debut was last week. Today is going to be episode 2. He did a test a week before that, and it was phenomenal. So he's going to do it live when he can, and he will take live requests. It's going to be a lot of fun. But, you know, he's also with KGRA, so he produces every weekend, and he does shows until about midnight his time, so he won't always be able to escape a few minutes early to get there live, but he's going to when he can. It's going to be good times. And for some really awesome music, you can check out Johnny Unitas. He's doing a show Wednesday at 8 p.m. Eastern on Wednesdays. It's a variety of music, and his debut show was just a few days ago, 2 days ago on Wednesday, and it was a great time. I think everyone really enjoyed themselves. I don't know what Mark's doing. I'm waiting. I'm running out of things to say, guys. What does everyone have planned for the weekend? You tell me some stuff. I have nothing planned this weekend. Usually Sunday night I'd be doing Sky Tour Radio, but apparently there's a football game on instead. Yes, it's that time of year again where you can go check out the Super Bowl. Or the Super Bowl. Time anyway. Or you can check out the Puppy Bowl and the Kitty halftime. I'm gonna look for that. If I even remember. Honestly, unless people were talking about it, I don't think I would know. I don't really watch a lot of TV, and I certainly don't follow football. Or any sport, really. As long as Toronto's doing well, and I don't think they're playing anything right now, so.
Alright, I'm back, but I'm going to run upstairs really quick out of my observatory office here, and I'm going to grab some orange juice, if you don't mind. It'll help me. Alright.
Go for it.
Alright, I'll be right back.
Because I wasn't running out of things to talk about already. Mark's gone to get some orange juice. But good for him. I mean, he obviously needs it, and how he can keep going for hours and hours on end, I don't know. But we certainly appreciate you hanging out with us this whole time. And I know some people have to come and go, but anytime you guys drop by, it really means a lot to us. And I think it really means a lot more to him, knowing that people crave this kind of information, this kind of science, and this kind of fact-based information, you know? It's not all glitz and glamour. Well, I shouldn't say that. It's not like a big show. This is how it is. This is real time, real astronomy, you know? I think the universe is glamorous enough with some of these shots. I mean, some of them are quite unreal. Some of them are so, I don't know. Just the colors, the vibrancy. It's lovely. Yeah, he's talking about the Ninja Games. Please, no spoilers. I haven't seen the World versus Europe and Australia yet. Hopefully it was taping tonight. I don't know if it is. If not, worst case scenario, I have a mirrored version that our good friend Johnny Unitas sent me. And check out his show. He has one Wednesday at 8 p.m. Eastern on Nerd Radio. I'll drop that link again. And he's also doing Sunday with Sinatra. You can check that out noon on Sunday, noon Eastern. Good times to be had for all. Well, there's the link in chat. Check it out. And welcome back, Mark. He doesn't have his headset on yet.
Okay.
Welcome back.
Thank you. Lafayette, I am here. So, I changed the battery. And we are sitting at 100% out there now. I'm not at 100%, but I'm okay. Now, let's check out something else. I was going to go to one particular location. Oh yes. What I did was I moved the dome to give us another view west of Sirius here. I'd like to just go through some of these areas. They're a little murky, okay, but I do want to showcase them a little bit. Okay, for instance, NGC 2309. It's a little star cluster. Okay. And it's got about 100 stars in it, maybe a few less. But I'm going to take us there. And here we go. And we can follow the bouncing observatory telescope. Here we are. Let's do this. You can see that we're doing pretty good here, looking out of the slit right here. Aiming out right there. That's good. So now we're looking in an area that's looks fairly devoid of anything until we take a picture. 20 seconds at 12,800. They're talking about you.
I know. They're not talking about me. We're
Sumo.
discussion. Sorry.
All right.
No. Sumo.
Yeah, sumo wrestling.
Oh. I just saw Tony's.
So there you see this beautiful little cluster right there, sitting out there. Amazing, you know, how these clusters are so rich. You know, this one's actually only got 50 to 100 stars, but it's just beautiful overall. You know, they're sitting out there. Every time you see a cluster, you're looking at the result of stellar furnaces that have created this environment where stars can form and create this beautiful and utterly amazing tapestry out here. And this is actually a bad shot because it's trailed a little bit, but I think it's because of my anxiety to get it get the picture taken. I'm gonna do it again just to get a good shot. It might also have a little bit of wind too. Hey, Joe Dare. Now there's a better shot. Okay, you can see now the cluster here. And as the algorithm gets rid of the noise, okay, you can actually see it a little better. Still got a little trailing to it. So, rather than try and fix that, I'm just going to move on to another cluster. You saw it. This is these beautiful little clusters are out there. It's amazing how many there are. There's just literally an absolutely amazing number of clusters. And then we have this one, which is another cluster. And let's check this guy out. NGC 2302. Right near 2309, which is where we were. So let's check you out. Go there. So we're moving over. We're only going to the west a little bit, and then the cluster are going to live right in here. All right, let's move up a little bit and over a little bit. And now let's take the 20 seconds at 12,800.
Did we look at M5?
No, We have not looked at M5.
Is it around?
I'm not sure. Oh, there's a beauty right there in the center. That's beautiful. No way. I got one of those notices just now. Windows wants to reboot and install. It's Windows 10 goodness. Usually that means the machine stops working for me. So I said, no way. I think M5 is in Serpents, and I'm not sure if that's something we can find right now. Let's take a look and see. Yeah, I didn't think so. See where it is? It's not up yet. M5 is actually below the horizon right here. There's M3. Things that are this low on the horizon.
Sorry, Raymond.
Yeah, sorry, Ray. Things are this low on the horizon. If you notice along the sides, you can see the height. Okay? 10 degrees, 5 degrees, 10 degrees, 15 degrees. Usually, we don't see things that are good until they're well over 30 degrees above the horizon. They have to be above 30 degrees to actually be good enough to check out, really. Okay, and that's unfortunate, and I apologize for that. But it is what it is, you know. So we just did 2305 or 2302 rather. Now let's check this guy out. This is the heart-shaped cluster. I like going down to this one. Just take a little trip down Cluster Lane. All right, and let's go and figure out. Here we go. It's okay, Ray. It's a beautiful cluster. When you check it out in a second, you'll say it is too. You'll agree. I'm going to go down to 10,000 just to drop the noise a little bit. But we'll do 20 seconds anyway. If anyone's got any questions, let me know. I will be happy to try and answer them for you. That's beautiful. You'll notice that this cluster actually has a couple of reddish stars, probably K-type stars in it. They might be field stars. Meaning that they're either closer or farther away, because clusters generally are about the same age. And if we're looking at red stars, especially if they're, say, giants, then we know they're evolved. And the evolution of stars in a cluster is pretty much all the same. That's the thing about clusters. They're all born at the same time. And the stars are all born at the same time within a particular cluster. So most likely, there won't be any oddball evolution going on in any of these. Okay, let's if you want to see any more of these, let me know. I mean, I'm okay to let you see more. Now we're going to come down here to the Seagull. I want to try and see if we go to this star right here. I want to see if we can pick up this little dark lane here. This dark cloud. And here we go. Let's go try and see if we got it. So we're moving down to it right there. And these stars you're seeing here correspond to these stars you're seeing here. So let's make sure, well, actually, kind of not lined up exactly in the same place. Let's go see. Let's just do it. 10,000 for 20 seconds. Oh, I forgot to determine whether the telescope is... Oh, good, it stopped. Sometimes the telescope takes a little longer to lock in.
Is that ice I hear you crunching?
Yeah, I'm not supposed to be crunching ice. It's not nice. I just happened to get some, so I crunched it and hoped nobody would notice, but unfortunately, you outed me. You totally, got everybody now is all mad at me.
No one's mad at you.
Okay, obviously tonight is not the night where we're going to see this dark lane in the Seagull Nebula. But we're keeping going. We can check it out. Keep moving along. Find new objects. I'm okay with that.
I like new objects.
Yeah.
Is Vulpix around? Vulpecula?
No, that's the constellation that is right near Cygnus. And we know where Cygnus is right now. On the other side of the planet. In the daytime sky. I'll have you understand that at some point. I'll get you to understand that. Okay, let's go to NGC 2345, which is a nice open cluster. Okay, it has well over 100 stars in it. It's pretty. So let's go check it out. Initially, you can't see anything, but maybe if we were to go into a 4K mode and then increase the sensitivity, we can start to see the stars showing up, you see? Now we're seeing more stars. But I think that it's interesting to just try and do a straightforward photo. We're going to do a 20 seconds for 10,000 on this. Here we go. Exactly, Joe. There's no ice crunching here. How pretty.
Ooh, that's an interesting question from Cryptic. Have you ever speculated on whether you think Betelgeuse has ever gone supernova yet?
It's a Betelgeuse, but I know what you mean.
Oh, well.
That's all right. That's probably one of the most often mispronounced names in the English language.
Betelgeuse?
Betelgeuse, yeah. The answer to the question is yes. I've often wondered, being that it's just about 500 light years away, if it's gone off in the past 500 years, we wouldn't know about it until the light train reaches us that signals its demise. The light train being that explosion incident. And that's what's interesting about space. If you're traveling to a long distance destination, by the time you get there, your destination may not be there anymore. Or it might have changed. Certainly it won't be in the same place. It's going to move. You have to go where it's heading. So you have to intersect it. You have to, intercept it on a course. You can't, just fly out to a star and expect it's going to be there when you get there. Do you know why that is?
No.
It's because everything is orbiting the galaxy. Our sun has orbited the galaxy about 19 and a half times since we were formed. You know?
So basically, we're never going to see anything ever go supernova. We're only going to see the end results from it. Unless we're actually like staring. No, even still, we won't see it at the exact moment. We'll only see the after effects, right?
We'll see it. We'll see when the light gets to us. That's when we'll see it.
Yeah.
Yes.
Exactly. So we're never actually going to.
You'll never see anything.
Like even if we have our all the telescopes aimed at it right now, from now until it goes off, it's only going to be when that light signal hits us.
Right, but we won't miss anything. We just won't have the.
How can you say that?
We're not going to miss anything. We're going to see it just before it happens. Then we'll see it as it's happening. Then we'll see it after it's maxed out. And then we'll see it as it's waning, going dimmer again. It's called a light train. The light train. The train of light coming from that star.
Yeah, but like say if the sun went out, it would take 8 minutes before we realized it.
Right.
Because it takes 8 minutes for the light from the sun to hit Earth, right?
Yeah. Mm-hmm.
Am I saying that right?
Yeah.
Okay. So if all of a sudden the sun went out, and I know it's not just going to go out like that, but it would take 8 minutes. So however far away, say it's Betelgeuse for this instance, like say it's, how far away did you say it was?
500 light years.
Okay, so it would take 500 years for the light change to hit us.
That's right.
So we would have. So how could we see back those 500 years that we missed?
We didn't.
Do you know what I mean? It's all going to be.
No, you didn't.
Inferred.
No. You're going to see it as it happens, as far as we're concerned. See, the light is taking time to leave the area after, say Betelgeuse goes supernova right this instant.
Yes.
Okay. For 500 years, Betelgeuse is going to be shining bright orange in the sky. Then suddenly Betelgeuse is going to get really bright in the sky. Whoa, what's that? Then if you look at it, you'll say, oh, Betelgeuse is exploding. Wow, there it goes. Okay, we're going to get a complete record of Betelgeuse exploding. We're not going to miss anything. It just takes time for that light to get here. We're just going to miss the actual time the event occurred.
Yeah.
We're not going to miss the event. We're going to see it in its entirety. So we're not going to miss a thing because the light is streaming to us from Betelgeuse all the time. And if it just goes supernova somewhere in there, well, then we're going to see the light coming to us, and then boom, we're going to see the supernova light get to us and then pass us. And then as it dims away. So we're not going to miss a thing. Make sense?
Yeah, it makes sense, but I'm sad now because we probably won't see it in our lifetime. Unless it happened like 500 years ago, right?
That's a very good point. That's a right way to say it. If it happened about, anywhere between, say, 375 and, 500 years ago, then you might have a chance of seeing it.
And there's no way of telling until we see that light. There's no way of telling until it happens, basically. Would tell us that it already happened.
That's correct.
Weird. That's a weird sentence to say, even.
We can't look back. We can't predict the future. The light, the universe is a time machine. Everywhere we look in the universe, we're looking at it as it was, not as it is. Everywhere. And that's what's interesting about the universe too, is that we're looking at it only as it ever was. And the farther back in the universe we look, the farther back in time we're seeing.
What's the closest thing we can do that to where we might actually be able to see it in real time?
Earth, looking at other things happening on the Earth, and you're still going to see it some nanoseconds after it occurred. Watching a bird fly by, there's a discrete and definitive amount of time it takes for the light from the bird to reach your eyes. See what I mean?
Kinda.
Yeah, you do.
I like Charles' explanation.
What's that?
Think of it as running a live stream with a 500-year delay.
Exactly.
It'll
heck-
catch up, and then we'll still watch the full thing.
And a heck of a lot of
Interrupted. Yeah, I
buffering.
get it. It's cute.
Yeah, he's right. That's how it'll be.
And Tony wants to know, do we have footage of supernovas from NASA? Or from anyone, for that matter?
Actually, yeah. I mean, there have been some supernovas that have gone off that we've actually captured. When, for instance, the most recent ones were the ones that the LIGO detectors detected. And those were the kilonovas that were way bigger than supernovae. And when we saw those happen, what we were seeing was, this merger of black holes or merger of neutron stars that generated gravity waves. Waves in the interstellar medium that are so powerful that they're composed of gravitational forces, and they ripple through the universe, reaching us after many, many millions of years of travel through space. And then the detectors on the Earth pick them up. So if they were the death knell for a society, the societies stopped living millions of years ago. And only now did we see and see the remnant of their unfortunate demise when those signals finally reached us. So it's a pretty catastrophic thing, So I'm going to just come up here a little bit, because the object we're looking at right now actually kind of helps illustrate this pretty well. And I'll do 20 seconds at 12,800 on this one. I went too high. Let me bring it down just a little, and then I will bring it back to us. Okay, I'm just going to bring it back down a little. Now we'll take this picture. Kind of hard to see it tonight. It's not the best night, but you know what? This will help. A little processing. Okay, we're looking at something we looked at before. This faint bluish illumination is an object we've known as Thor's helmet. But
This one.
yeah, but how Thor's helmet formed is really odd. First of all, you'll notice the color. It's not that typical blue like you see of the Pleiades. And there's no blue star that seems to be around here to illuminate this thing and cause it to reflect light. That's because this is actually something different. And I'm going to give us a little more processing here to kind of accentuate it a little bit. Okay, we're looking at an object that has been generated. Okay, this object right here, this is actually a bubble of gas that's blown away from a central star that's known as a Wolf-Rayet star. And a Wolf-Rayet star, that's W-O-L-F Rayet, R-A-Y-E-T, also known as a WR star. These are very hot stars, and they're very odd because they stand out amongst other stars in the following way. When an ordinary star emits or expels its outer envelope during a planetary nebula phase, it's actually there's a lot of hydrogen gas in this outer envelope that's being expelled, and we see the oxygen 3, this blue color that we see here. But with a Wolf-Rayet star, many times we don't actually see any hydrogen. It's like it's missing. And it has to do with the way the star evolved. When the star evolved, it actually ended up using up that hydrogen, and it ended up creating mostly this oxygen 3, which is really odd. So it's a very different type of nebula that's created, and the star is very, very hot in the center. Very much hotter than the typical like white dwarf that you get. So it's really not the same as a white dwarf scenario. All right. However, it's still interesting in its own right. So Wolf-Rayet stars have a place. They populate the interstellar medium with all kinds of material, and it's very much they're odd. You can't survive near them. The ultraviolet radiation is immense, and because of that, you would die rather quickly. So luckily, we don't have any near us. So yes, you can see shapes in this. I'm sure you can. Let's check out one more object here. Yeah, I think, unfortunately tonight we don't have the best night, so I can't really, if I start doing nebulae, unfortunately, we need a good night for that, you know. So unfortunately we're not able to do that. Let's try this one anyway, just because I want to show you that this is a planetary, and it kind of shows you where I'm going with this. All right, so let's do this. Let's see if we can go there. Okay, here we go. And the planetary we're going to is one that's called NGC 2438. All right.
Oh yeah.
What do you mean? Oh yeah.
I want a better name than that.
You don't like that name?
Not really.
Wow.
Wait, you think it flows off the tongue?
Yeah, it seems nice. You know?
Get out of here. Is there another name for it?
Yes.
Would you please tell us?
Yes, PGC 3517755.
That's a worse name.
Or PK 231 plus 4.2.
Well,
or
PK's all right for Paul and Keith, but
that's it. Or PN for Planetary Nebula G23.8 plus 0.04.
no, decimals is the worst one yet.
Well, I gave you decimals before. But yes.
NGC, at least I'm a little more familiar with the new general catalog.
Oh, very well done.
Ooh.
Did you remember that, or somebody tell you?
I remembered. That's why I said it's slow, because I wasn't 100% sure about the J. Because general is pretty general. I didn't know if maybe it was something else. The new general catalog, yeah.
The new goody
Familiar with that one.
The new goody catalog. All right, well, let's check it out. 12,800 ISO, 20 seconds.
No, out of all of them, the NGC was the best, but I was hoping it was something like, the rabbit or the whale.
Yeah, I know.
I knew it wasn't Lepus or Cetus, but...
Yep.
Oh, did you see what I did there?
Look at that.
Did you see what I did there? No acknowledgement.
I didn't.
Well, it was clever for people in chat that caught what
You
I
said
did.
Cetus or Lepus.
Yeah, I said a rabbit or a whale.
Yeah.
And then I said Lepus or Cetus,
Oh,
which is the rabbit and the whale.
that's right.
It's better when you don't have to explain.
Yeah, it is. But that was very good.
Thank you.
Yeah. Okay, I'm going to,
I didn't know I was going to do that.
well, that's okay. This is one we've seen before. This is a cluster of stars that has what apparently looks like a dying star in it, which is this planetary nebula that we see here. Okay. Now, that's why when I say this is a planetary nebula, it's also NGC 2438. It's actually the cluster, right, that has this planetary nebula within it, apparently. Although looks are deceiving. Okay, when we actually go back to and look at this object, really what we have to notice is that this cluster, all right, is actually farther away, and that this planetary nebula that we're seeing here is actually much closer to us. In fact, it's only half again as far as this cluster is behind it. So if we went to this, we'd go blazing by this planetary nebula when we got out about 2,000 light years. And then we got to the rest of the 4,000 or so light years that this cluster sits at, this planetary nebula would be 2,000 light years behind us. This is called superimposition, where it's just a star superimposed on a different, another background, another backdrop, so you can actually see what's going on. Isn't that crazy? Yeah. And notice the characteristic color, your favorite color.
I know.
This is that color of the planetary nebula.
I like that darker blue as opposed to the kind of greeny blue, the lighter blue of the ring and the dumbbell.
Well, and yet the truth is, that lighter blue is what it really is. This is a little bit modified to show the colors more clearly. It's not false color. I mean, there's a place for false color. We can take, like, for instance, we can go in here and say, well, can we change the view to make it a little easier to see? And we can change it to red, see? But it's not red. Again, it's not really what its color is. But that helps us see some of the detail. Some of the colors show detail better than others. Blues are hard for people to see. So if we change...
I find that so relaxing on the eye, though.
Yeah, that's true. And then we can do this, okay, and make it almost vanish when we go into the purple, see?
Wow.
All right? But this is, the real color is right about like that. Which is really kind of cool. Really cool. You know, so this is that beautiful planetary nebula within the cluster. At least it looks like it is, but it's not. It's a superimposition problem.
I thought that was you banging on the desk for a second.
Oh, I could do that. I can always, I've always added to music like that, you know, like just play it along, like. That comes from being a drummer. Okay, so there we go. And I'm gonna, I think I'm gonna end tonight on this object because we've made good on our travel plans to go traveling through the northern star clusters, and I am going to probably just go close down the dome and do some image processing for all of you on the northern Trifid that we took pictures of earlier. So I hope you guys had a great time Amanda,
And I hope to see some of you over at Earth Radio tonight. It starts in an hour. Skywatchers Midnight Metal Madness.
yeah, the old New York Skywatcher. If you like my
Earth
music,
Radio.
if you like the music for this stream, you will not like his. Heavy metal, man.
If you want to rock, I will see you tonight.
There you go. Until then, guys, you have a good evening, and
Have a great weekend.
exactly, and keep looking up. From Amanda and
While you're
I,
driving.
from Amanda and I at Sky Tour Livestream. Have a good evening, everybody, and we'll talk to you soon.